In this video, we're going to be talking about how to graph straight lines. There's a couple of key ideas that we're going to talk about before we're going to get into some examples. The first key idea is that the gradient, which we use m to represent the gradient, is a number that describes the slope of a line. And the way we find that, generally speaking, is we find how the line rises over, and we divide it by how it runs. What we mean by that is, given, say, this line here on the x and y axis, we can pick 2 points. So say we've got this point here and this point here. If we find the difference in how high they are, so that's the rise, and we do the same for how far across they are from each other, that's the run. If we divide those, we'll find the gradient. Another key idea is the intercepts. Now, what the intercepts are, if you think about like in rugby, a pass might be intercepted by the other team. That's where there's a line, say that's the direction of a ball, and where it intercepts is where the opposing player might take that ball. So if we want to think about the x-axis, where does the line intercept it? Well, it intercepts, in this case, at this point here, that's the x-intercept. And for the y-axis, the line intercepts it here. So the way we talk about it is that the y-intercept is when x equals 0, and the x-intercept is when y equals 0. Another idea is that gradient can be calculated using the rise over run method. Another method is it can be calculated by using m, which is the gradient, is equal to tan theta. So that's this idea here. Theta is calculated, it's the angle between the line and the x-axis. So say this is the line here. Theta is the angle between this line and the x-axis there. Now, the reason why this works is because we know that this line is the rise and this is the run, given these 2 points. For theta, this is the opposite side and this is the adjacent side. Of course, this is the hypotenuse. We know that tan theta is the opposite over adjacent, given here. And we know that, well, that's also the rise over run. So if the opposite over adjacent is m, so is tan theta. And that's that idea. The fourth and final idea we're going to talk about before doing examples is the gradient-intercept form of a straight line. Now that is where we get given an equation of a straight line in the form of y equals mx plus b, or y equals mx plus c. These are the same idea. It's just depending on what question you're answering. They might ask you to find b, or they might ask you to find c. So just going over both here. Now m, given in either of these situations, m is the gradient, just like it is over here, and the number added on or subtracted on at the end, that's the y-intercept. So we don't have to calculate anything, it's given to us straight away. Now, if we were to graph these lines, the gradient will change the way the line looks. If it's a positive gradient, it will look like this, or lean to the right. If it's a negative gradient, it will look like this, leaning to the left. If it's a straight flat line, that means there's no gradient because there's no slope, it's completely flat. If it's a vertical line, though, this is where things get a bit weird. You could say that it's got an infinite gradient, but it's probably better to say it's undefined gradient, because we can't tell how it's sloping. We know that there is some sort of slope because it's vertical, it's not flat, but we can't identify what it is. Now we've got those ideas out of the way, we're going to talk about some examples. So here's an example where we're deciding if a point is on a line or not. So the question, decide if the point -2, 7 is on the line with the given equations. So we can test this out. Now, the way we do this, we substitute in this point. So we'll sub in -2 and 7. And when we do that, remember that this is the x value. This is the y value. So given this is the x value, wherever we see x, I'm going to put that in brackets, and wherever we have the y value, I'm going to put it in brackets. Now in this situation, y is by itself, so I'm just going to put the y value, and in this case, because x is with another number, I'm going to put it in with brackets. And what that means is that we're just multiplying those two numbers. Okay, now you can either type this into a calculator, work it out in your head. We find that, well, this is of course 7, and this, negative 3 times negative 2, that's positive 6 plus 1. So that means 7 equals 7, and we know this is true. And we can say therefore, using 3 dots, that means therefore, negative 2, 7 lies on y equals negative 3x plus 1, just to be completely clear what we've calculated there, what we've shown. Now here we'll do it again for b. We're going to sub in that same point, negative 2, 7. And here we'll just do the same thing. We've got 2x plus 2y equals 1, so I'm going to put in wherever I see an x, negative 2 in brackets, and wherever I see a y, 7 in brackets. So we'll have 2 outside of negative 2 plus 2 outside of 7 equals 1. Remember, brackets means multiply, so this is 2 times negative 2 is going to be negative 4, and 2 times 7 is going to be 14 equals 1. So we'll evaluate this. Negative 4 plus 14, that's going to be 10, equals 1. And we know that doesn't work, so that's false. Therefore, negative 2, 7 does not lie on 2x plus 2y equals 1. Okay, and that's the answer for that example. The next example, we're going to do some sketching. Now this is sketching linear graphs using gradient-intercept form that we were talking about before. And this is already in that form. We'll see that this one isn't, so we're going to have to do some manipulation there. So find the gradient and y-intercept for these linear relationships and sketch each graph. Okay, so find the gradient and y-intercept. We know that as this is in the form y equals mx plus b or c, we've got our m is 2, so we're going to have our gradient is just 2, and our y-intercept is negative 1. Okay, so when we sketch a graph using this idea, we need to mark where our y-intercept is. So here's our y-axis, so the line's going to intercept at negative 1, so I'm just going to identify here that that is negative 1, and it's got a gradient of 2, so that means that for every point we go to the right, we go up 2 spaces. So that means that if we go across to 1, we're going to go up 2 spaces, so that's going to be here. That's of course 2 spaces, we've gone up to 1 there. If we go across to 2, we'll go up 2 more spaces, so we're going to be at 3. So that's our next dot there. You can see that we're starting to form a line. So if I connect these dots, we're going to get a bit of a line here. Okay, and of course, not measuring, we've got a bit of error there, but that's fine. It's pretty close. We can say that labeling that line, that's y equals 2x minus 1. Okay, we're going to do the same thing for b. Now b, it's not in the form that we want, so we need to manipulate it a bit. So I'm going to start off by rewriting it. Okay, and we want it in y equals mx plus b, that form, the gradient-intercept form. So I'm going to get everything over to the right hand side, excluding the y. So in this case, we're going to take away 2x. When we do that, the 2x is going to disappear from this side. We're going to be left with 3y is equal to 3, because that was already there, minus 2x. Okay, now before we keep on going, we've got a problem. We've got a 3 there. We just need to divide 3 from everything, really. The reason why we divide is because this is 3 times y. So if we divide everything by 3, we're going to get y is equal to 3 divided by 3 is 1 minus 2x divided by 3, that's going to be minus 213x. Okay, so when we do that, we'll end up, I'm going to do a bit of rearranging again just to get it in that form. We're going to have y is equal to minus 213x plus 1. The reason why is so it's in the form y equals mx plus b. Once we have that, we're going to label, like us, the gradient and y-intercept. So the gradient, which is our m, is minus 2 and 3. And our y-intercept is positive 1. Okay, so now we'll do the same thing. We're going to mark our y-intercept on the axis. So we're going to have 1 here. It's going to be 1. And the way this works, it's a little bit different because we've got a fraction. When it's a whole number, you just go across 1 and then up or down, whatever it is, depending if it's positive or negative. In this case, we need to go across whatever the bottom number is. So we're going to go across 3 spaces. So we're going to be at 3 here. We need to go down 2 spaces because it's a negative and there's a 2. So if we go down 2, we're going to be at negative 1. So that's our next dot there. So once we've understood that, we can just connect these two dots to form a line. And then we can label it. So you can label it with either the original one or the new one. I'm going to do it with the original one just because that's what they gave us. Okay, so that's the answer to that example. The second last example is going to be how to find x and y intercepts of linear graphs. So, sketch the following by finding the x and y intercepts. So, in this case, we don't need to have it in this form. What we need to do is we need to find when x is 0, which is the y-intercept, and when y is 0, which is the x-intercept. So, we'll start off with A. When x is 0, and we'll substitute everything in. So in this case, it's just going to be when x is 0. We've got y is equal to 2. We'll insert 0 where the x is, minus 8. So that is 0 minus 8. Therefore, y is going to be just negative 8. So that's our y-intercept. When y is 0, it's going to be a bit more working here. We'll substitute 0 in for y. So 0 is equal to 2x minus 8. And then we'll just do some rearranging. So we're going to add 8 to both sides. So when we do that, we're going to have 8 is equal to 2x. We need to divide both sides by 2. So we're going to have 4 is equal to x. Or rearranging again, x is equal to 4. So on our axes, we can put our y-intercept as minus 8. So here, that's going to be minus 8. And our x-axis, we're going to have x is 4. So we'll put that about there. Once we've got our x and y-intercept, we can just connect those two dots. And that is our line done. So that's another way of graphing lines. So one is with the gradient-intercept form. And this one, we're just using axes. Intercepts. So I'm going to label this. We're going to have y is equal to 2x minus 8. The reason why we label it is just to show that that line is in fact what we intended it to be. That we're not accidentally graphing this line on that axis. Okay, we'll do it again with b. I'm going to rewrite it first. Minus 3x minus 2y equals 6. Now once again we need to find it when x is 0. Because that is our y-intercept. And sub it in, we're going to have minus 3 times 0 minus 2y equals 6. So that means we've got 0 minus 2y, so I can just evaluate that to minus 2y equals 6. And we, of course, want y by itself, so I'm going to divide both sides by negative 2. So y will equal negative 3. So that's our y-intercept. We'll do it again. For when y is 0, we've got minus 3x minus 2 times 0 equals 6. That of course is just going to be 0, so we're going to have minus 3x is equal to 6, and we'll divide both sides by negative 3. We're going to get x is equal to negative 2. On our axes here, we can put those y and x intercepts. The y intercept is going to be negative 3. And our x-intercept is going to be negative 2. And we connect those with our line. Once again, we'll label it. And that's that example done as well. Our final example is sketching lines with one intercept. Okay, so for this situation, we've got y equals 2. It says sketch these special lines. You'll see why they're special in a moment. When y equals 2, okay, this is where it gets a little bit different. If we go over the same ideas that we're doing before, to find the y-intercept, when x is 0, well, in this case, y will still be 2. Okay, so that means that the line's going to cut the x-axis at y equals 2. Okay, when y is 0, we get 0 is equal to 2. We know that doesn't work, and that makes this a bit weird. Where does the line cut the x-axis? Well, in this situation, it doesn't, because 0 doesn't equal 2. And if you'll notice, there's no x, so there's no gradient. So when there's no gradient, that means we're going to have a flat line. So that's our line there. That's y is equal to 2. It only has one intercept, as the question's kind of telling us. Okay, we'll do it again for b. Now it almost is the same. The difference is it's an x instead of a y. So you'll see that when we find the y-intercept, when x is 0, we get 0 is equal to negative 3. And when 0 equals negative 3, that obviously doesn't work. That can't happen, just as this couldn't happen. So that means it's got no y-intercept. It's not going to cut the y-axis. But when we make y equals 0, we'll see, of course, that it stays the same. X is equal to negative 3. So that means that this line is going to cut at negative 3. And it will just stay that way, just with a vertical line in this situation. That's x is negative 3. So now we understand how to get a flat line and a vertical line. The last situation is it's not either. What we're going to get here is just, it still only has one intercept, but you'll notice it doesn't have a y-intercept given in this form. So we're going to have to go through it again. We're going to have when x is 0, which we'll find our y-intercept, we get y is equal to negative 1/2 times 0, which of course y equals 0. So that's our y-intercept. Our x-intercept is when y is 0, we'll have 0 is equal to minus 1/2 x. And of course we'll divide both sides by negative 1/2, and we'll end up getting 0 is equal to x, or of course x is equal to 0. So that means that the line's going to cut at the origin, at 0. So that's why it's considered only one intercept. However, of course, we know that's technically 2. It's just the same point. Okay, so how do we graph this? So it's the same idea for when we have negative 1/2. For every 2 we go across, we go down 1. So we're going to have 2 across here. We'll go down 1. Our first point, and we can just connect those lines. And that is going to be y equals negative a half x. Okay, so hopefully that gives you a good idea on how to sketch lines in lots of different situations.